Hello and Assalamualaikum. My name is Mohamad Haizi bin Noor. So today I'm going to present to you about our final year project. I'm I'm the leader for FYP team 056 doing the project barbot. So this is our poster. Oops. This is our final year project poster, which consists of three members, which is me, myself, Mohamad Haziq, and my team members, Mohamad Haizi Hassim and Mohamad Syazwan, with our beloved supervisor, TS Mohamad Sabani. Encik Sabani is our supervisor. So this is our poster and our detail for the project barcode, and this is the full complete replica. So for the next section, I will pass to my team member, Shazwan. He will explain about introduction, and the next Haizi will explain about methodology, and I will explain about the result and discussion for the last.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad Syazwan bin Azman. So, I will explain about introduction of barbot. So, first, a water dispenser is, as its name implies, a device that dispenses water. It is used to provide easy access to drinking water. Water dispensers have become a necessary part of society. A water dispenser can be useful in many situations. Some offices prefer to have water dispensers because it provides clients and employees with convenient access to water without having to take extended breaks or drive to the store. Then, water dispensers are commonly used in food and beverage companies, which is F&B. Water dispensers come in a variety of form factors, ranging from wall-mounted to bottle filler water dispensers, combination units, to bi-level units and other formats. They are generally broken up into two categories, which is point of use (POU) water dispensers and bottled water dispensers. POU water dispensers are connected to a water supply, while bottled water dispensers require deliver or self-pickup of water in large bottles from vendors. Bottled water dispensers can be top-mounted or bottom-loaded, depending on the design of the model. Most water dispensers typically use the same simple concept, which is to deliver water from a source through a tap or spigot, usually using a button or knob for users to dispense the water. In this video, we will discuss the procedure of barbot, which is smart water dispensers, and bartender machine. The barbot is a smart bartender machine model that can be controlled remotely utilizing a joystick seal consolidated with remote module and FYP056 plus PA and plus LNA. The main purpose of barbot is specially designed for food and beverage companies F&B such as Starbucks, Tea Life, Cool Block and others. It is specially designed to improvise their manual drinking dispenser machine because on the off chance that there are an excessive number of the client going to their shop, the beverage that should be served to the client might be late because the water dispenser machine speed is the lack of effectiveness. With the nearness of barbot, it can expand the effectiveness of the gadget machine and lessen the work should be finished by the specialist. In this way, it can likewise be controlled remotely in the food and beverage companies F&B. Next, I want to explain about the problem statement. Nowadays, most food and beverage companies F&B had manual drinking dispenser machine inside their shop. But if there are too many customers coming to their shop, the drink that need to be served to the customer may be late because the dispenser machine dispense speed is lack of efficiency. The barbot is a dispenser drinking machine prototype that can be controlled wirelessly using joystick shield combined with the wireless module and RFL24L01 plus BA plus LNA. With the presence of barbot, it can increase the efficiency of the dispenser machine and reduce the work need to be done by the worker. Thus, it can also be controlled wirelessly. Next, I will explain about our objective. First, our objective is to design and build a flexible dispenser machine using 3D printed components. Then, we want to create an electronic circuit that be able to actuate the dispenser cup pad and dispenser water pedal wirelessly using joystick shield. And then, we want to design a complete dispenser drinking machine, which is barbot controlled by joystick. That's all from me, Mohamad Syazwan bin Azman. So, thank you very much.
Hi, my name is Mohamad Haizi. I will be presenting about project scope and methodology. First is the project scope. Project scope is the barbot machine are able to move the dispenser water pad and dispenser pedal. Next is barbot machine are able to prepare the drink without need to touch the dispenser, but the drink must be taken by the worker. And lastly, barbot machine is controlled wirelessly using a joystick shield attached to Arduino Uno. Next is methodology. There are 4 main points for the methodology. First is the methodology research, which contains a block diagram, freezing circuit sketch diagram, and project flowchart. Next is project simulation using software, and then project building by stage, and lastly the coding programs. First is the block diagram. It starts with the input with an RF24L01 wireless radio module and go to the microcontroller Arduino Uno, which the power supply is 12 volt battery, and then connected to the control panel, which is the joystick shield. The output from the microcontroller Arduino Uno is motor, which there are motor A, motor B, which control the dispenser pedal, and then motor C, which control the dispenser cup pad, and the output for LCD, which is liquid crystal display for the drink menu. Next is the freezing circuit diagram. This is the circuit diagram that we construct using the freezing software. This is the physically constructed circuit diagram. You can see there are Arduino Uno, LCD drink menu, the motor B, motor C, the motor driver. There are 2 motor driver, and then the motor A. The motor A is connected to the motor driver, this one, and the other motor driver connected to motor B and motor C. And then this motor driver is powered by 12 volt battery, and then the input is the NRF24L01 for the wireless controller. It's connected to the Arduino Uno. Next is the project flowchart. Project flowchart start here, and then it will activate an RF24L01 transmitter radio signal attached to joystick module. Then activate an RF24L01 receiver radio signal attached to Arduino Uno, and then put cup on top of rectangle graph. User rotate joystick knob and press joystick button. This is the command for the barbot machine. First is the x-axis joystick rotate. When the motor A rotates, y-axis joystick rotate, and then motor B and motor C will rotate. Button A press for the LCD display drink 1 name. Button B press for LCD display drink 2 name. Button C press for LCD display drink 3 name, and the button D press for the LCD display drink 4 name. Then motor A rotates, making the cutoff pad moves horizontally, while motor B and motor C rotates for the dispenser pedal moves vertically. And then is project simulation using software. We use the Proteus 8 Pro for the simulation. We connected it as shown in this diagram. We connect it in this, and then we simulate it using the Proteus 8 software. Project building stage 1. The stage 1 include in 3D printing the mechanical parts for barbot, which we designed earlier, and then printed under Makerspace UTHM by Encik Syukri bin Ahmad with collaboration with FYP056 grant. The diagram shows the finished product of the printed mechanical parts for the barbot. Then project building stage 2. Stage 2 involves in a pre-mechanical test for the barbot replica. The pre-mechanical tests include measuring the distance for mounting the component on the table and examines all printed components for any faulty. After complete testing, mechanical inventory items and electronic items ready to be prepared to integrate with the printed replica to complete the prototype. Next is project building stage 3. Stage 3 is the process of creating a circuit and conducting pilot tests to make sure the circuit works before integrating it with the mechanical parts. The pilot test is essential to detect errors such as short circuit and ungrounded wires in the circuit, which will make the circuit not working. And then for the last stage, the stage 4 is where the electronic parts and mechanical parts are combined together to complete the basic construction of the barbot machine. Then the next step is the coding programs. We use the Arduino IDE. Arduino is connected to the PC using the USB cable. A quick setup is made and the needed library for the code was installed to start the coding. The coding for the barbot machine consists of series of programs. There are two sets of code programs needed for the controller to work, which is the code program for the transmitter and code program for the receiver. And then for the basic functioning programming, it was made by using several logic functions and linking together the address with the serial ports where the pins are connected. Thank you.
Okay, we are back. My name is Mohamad Haizi bin Noor. So I'm going to discuss about the result and discussion that we obtained from the project barbot that already have been made. I'm sorry. So this is the complete prototype for the barbot. This consists of the electronic circuits, the printed mechanical replica, and the gas bottles, which is connected to the pump. I call it optic pump to release the water from the gas bottle. So next is prototype label. Prototype label, as you can see over here, this is the bottle drink that I just said just now. This is the bottle drink, and this is the cup rough pad. Cup rough pad is the rectangular one, if you can see over here that I circle it. That is the cup rough pad. To the cup rough pad function is we want to put the cups on top of the barbot rail, so that when it moves, it can choose user can choose which water it want to dispense based on the joystick controller over here. And the I2C LCD is we use to display the drink name, and when the user click on the push button over the joystick, it will display drink 1 ready, drink 2 ready, drink 3 ready, and drink 4 ready. That is the function of I2C LCD. And why do I use I2C LCD in this project is because it use less pin and it is easier to programmable and easy to troubleshoot. If I use the normal LCD, too much pin, and maybe I had to change my board to Arduino Mega, and it already consume a lot amount of cost to buy Arduino Mega compared to Arduino Uno. That's why I use I2C LCD. And this is the circuit box. The circuit box is used for finishing process. It is better to keep the circuit inside the box, so that when if the water is spilled from the optic, the water will not spill into the circuit. So that's why the circuit box is used to keep the water from at the circuit box is used to keep the water from dripping into the circuit, avoid open circuit and short circuit, so that uh, the circuit can work properly. That's why it must be kept inside the circuit box. And here you can see this is the DC motor. The DC motor that I use is about for DC motor of X-axis is about 388 RPM, 388 RPM. That means it can carry about 0.8 kg of torque. So when we talk about torque, you can see the y-axis over here. The y-axis, actually you need to use the more heavier torque, because if you use about 0.8 kg torque motor, the pedal cannot rise. That's why I use 3.8 kg 3.8 kg torque, which about 870 rpm of motor to make the pedal rise. So next point is joystick level. Joystick level, as you can see over here, this is the joystick level. Like I said, the push button is used to, actually this is push button A, B, C, and D in the coding that already been write and upload and troubleshoot and debug by me. So this is the push button for LCD display ring 1, ring 2, ring 3, and ring 4. And the controller is over here. You can see this is the real controller to control the machine. For the left one is had no function because I had not programmed it. Actually, you can see why the X at the Y axis is used for left and right, because the coding for DC motor and joystick controller is using X map coding. That's why uh, it is like it is like this. You can see the right function control two types of motion inside the cup rough pad. It allows this pencil to move up and move down. That's why it is called X map and Y map coding for the joystick controller. Next is the tabulation of data. You can see the tabulation of data is this is the cup rough pad, or I simplify it into cup pad. This is the pedal. This is the pedal and I2C LCD. This is the I2C LCD. So when this is the joystick move up, it will allow the cup pad to move right, and when it moves down, it will cause the cup pad to move to the left. So that is the basic function. While the pedal is, you can see from the y-axis, if this green button means like the joystick move to the user press the joystick move to the right, which allows the pedal to move up and move down to allow the water to spill, to be poured into the cup, into the rectangle cup of pad. So that's how it functions. And for I2C LCD, of course, the joystick controller doesn't do anything. Only the push button. You can see if the push button is pressed over here. The push button is pressed. When the push button is pressed, it will display ring name 1. And when I2C LCD, when joystick button is pressed again, display ring 2, ring 3, and ring 4. So that's how these three main components for barboard works. That's why I implement it into tabulation of data so that the user can understand easily. So for the conclusion, dispenser machine is a common device that usually installed in most of food and beverage stores. With the barboard technology, it makes the usual troublesome work to become more easier and efficient for the worker. Barboard be easily operated by any employee by using the joystick controller, which is wireless and easy to handle for the new employee. The main impact for this project for the industry is that the workflow will be more efficient, which will greatly reduce the total cost of expense for a company, while the society they can enjoy their favorite drinks without waiting for a long time. For a long time, we achieve all of the objectives, which are design and build flexible dispenser machine using 3D printed components, create an electronic circuit that are able to actuate the dispenser carpet and dispenser water pedal wirelessly using joystick shield, and design the complete dispenser drinking machine barboard control by using joystick. So the objective actually is achieved. But for the improvement to make this machine become more better, we maybe can replace the y-axis motor to about 1.2 kg, so that when the user press the x-axis right, it will allow the motor to move faster and drink can be prepared with more faster, maybe about 2 seconds, so that the drink can be poured. So that's why the project still needs improvement for future work, while our objective is still achieved. So next we'll be watching how the demo works. So let's watch how the barbot works. That's it from me. Thank you.